Welcome to our quantum deep dive. Today, we're taking a bit of a shortcut, maybe, to understanding a really revolutionary idea, how quantum mechanics might just transform the way we make sense of, well, huge amounts of text. We're diving deep into quantum topic modeling, and we're basing this on the insightful work in Yuri Schnippet's essay.
Exactly. Yeah. Think of it like peeling back layers of information overload, but with a totally new kind of lens. We'll explore how this groundbreaking approach aims to get past the limits of current text analysis, and maybe what new possibilities it really opens up for you for understanding complex data.
Okay, let's unpack this a bit. Before we really jump into the quantum stuff, what exactly is topic modeling for those following along? And maybe more importantly, why do our current methods, which are pretty powerful, right? Why do they need such a, well, radical upgrade?
Right. So at its core, topic modeling and NLP, natural language processing, it basically helps us automatically find hidden themes, hidden structures in these massive text collections. Classical methods, things like LDA, Latent Dirichlet Allocation, which essentially looks for word patterns that cluster together, and assigns topic probabilities. And also NMF, non-negative matrix factorization, which breaks documents down into topic components. They've been, honestly, incredibly powerful.
Yeah, they really have changed the game.
They have. But they do hit some serious hurdles, especially when you scale up. One big one is just computational complexity. It takes a lot of power for truly massive data sets. And secondly, they have this limited ability to really grasp the semantic ambiguity. Think about that word, bank, financial place, river's edge. Classical models, they kind of struggle to hold both meanings at once. They often force a choice.
Yeah, I see.
And we'll finally getting really coherent, distinct topics without tons of manual fine-tuning. That can be a real challenge too.
That bank example, it really drives home the point, doesn't it? So, okay, if classical methods are hitting this sort of wall, how do we bring quantum physics into it? This is where it starts to feel a bit sci-fi, maybe. How does quantum help solve these really nuanced problems?
Well, quantum mechanics just offers fundamentally new ways to process information. It's not just 0 or 1 like classical bits. We're talking about principles like superposition, a qubit, a quantum bit. It can be multiple states at the same time. So apply that to text. A word, or even a whole document. It doesn't have to be pigeonholed into one topic. It can exist in this overlay, this mix of various topics simultaneously. It naturally models that ambiguity we just mentioned.
Whoa, okay, so a document isn't just topic A or topic B. It can genuinely be both, or maybe bits of several, all at once. That really reflects how messy human language actually is. That feels like a big shift.
Precisely. It's a much richer representation. And it doesn't stop at superposition. We also have entanglement. This is where quantum objects get linked, sharing a fate no matter how far apart. In quantum topic modeling, entanglement could let us find these incredibly subtle, deep connections between words or ideas, connections that traditional statistics might just miss completely. It's like finding hidden threads.
Invisible threads, wow.
Yeah, and then there's interference. This lets us sort of selectively boost the signals of relevant topics, or conversely, cancel out the noise from irrelevant meanings. Think of it like noise cancellation, but for semantics. It leads to much cleaner, more precise models.
Okay, interference as semantic noise cancellation. That sounds incredibly powerful. So bringing this all together, what does this actually mean for the future? For understanding information, for us trying to navigate news or researchers looking for that next big thing. What are the tangible benefits?
The potential is just immense.
Ah.
I mean, theoretically, we're looking at exponential speedups for analyzing these enormous text data sets. Think about classical methods taking days, maybe weeks. A quantum approach might potentially do it in minutes or seconds. We're talking reducing computational complexity from something like, say, O(n) log W, which grows fast, to something that grows much, much slower, maybe O log n or O poly n, in some specific setups. That's huge for scale.
That difference in scaling is just staggering.
It really is. And beyond speed, it offers a more dynamic, context-aware way to represent topics. It handles that semantic flexibility much better. So imagine, finding breakthrough insights in scientific papers much faster. Or maybe much more accurate sentiment analysis, better fake news detection. The applications are pretty broad.
That vision is really compelling. But, okay, let's be realistic. We hear about quantum computing breakthroughs, but also about the challenges. That exponential speedup sounds great, but doesn't it need, perfect quantum computers? Are there still big hurdles before this is an everyday tool?
Oh, absolutely, yes. We're currently deep in what's called the NISQ era noisy intermediate scale quantum. That means basically we have a limited number of qubits, and they're quite error-prone. They lose their quantum state easily. So while the theory is exciting, practical implementation today often means using hybrid models.
Hybrid, meaning mixing classical and quantum.
Exactly. Combining the strengths of both, maybe use quantum for a specific, really hard subproblem like feature extraction. Well, classical computers handle the rest of the workflow. The future really depends on hardware getting better, more stable qubits, better error correction, and, of course, we're finding the quantum algorithms themselves. It's definitely a journey.
What a fascinating deep dive. It really feels like quantum topic modeling could be a paradigm shift, moving beyond just statistics, using superposition, entanglement, interference. It's like upgrading from a magnifying glass to a quantum microscope for text.
Indeed. It's early days, for sure, but it could fundamentally change how we navigate this information explosion around us. This whole concept, explored so well by Jürgen Schneppet, gives us a real glimpse into a future. A future where understanding complex data isn't just faster, but maybe far more nuanced, more insightful. It makes you wonder, doesn't it? If machines can grasp text in multiple dimensions like that, what new things will we learn about human thought itself?
A really provocative thought to end on. We hope this deep dive has definitely sparked your curiosity about this quantum frontier of information. For more on this really cutting-edge topic and the work of Jürgen Schneppet, you can explore schneppet.du. Until next time, keep exploring.